Hey there, science fans! Today we're diving into the fascinating world of melting and boiling points. Everything around us is made of tiny particles called molecules. These molecules are always moving, even in solid objects. Now imagine heating up an ice cube. As the temperature rises, the ice molecules vibrate faster and faster. Eventually they break free from their rigid structure and start sliding around each other. This, my friends, is melting. The melting point is the exact temperature at which a solid transforms into a liquid. For pure water, it's 0 degrees Celsius or 32 degrees Fahrenheit. Pretty neat, right? But here's the thing. Melting points can vary depending on the substance. Take iron, for example. It has a much higher melting point than ice, around 1,538 degrees Celsius, or 2,800 degrees Fahrenheit. That's why we use it to make things like buildings and bridges. It can withstand some serious heat. Now let's crank up the heat even further. As we continue to warm our liquid water, the molecules move even faster and with more energy. Eventually they gain enough energy to escape from the liquid phase and become a gas. That's what we call boiling. The boiling point is the specific temperature at which a liquid changes into a gas. For pure water at sea level, it's 100 degrees Celsius or 212 degrees Fahrenheit. You know, the temperature at which water merrily boils in a teapot. Just like melting points, boiling points also depend on the substance. Different substances have different boiling points because of the forces that hold their molecules together. We call these intermolecular forces. Here's a fun fact. The purity of a substance can actually affect its melting and boiling points. Think of it this way. Imagine a group of perfectly synchronized dancers. They move together flawlessly, right? Well, pure substances are like those synchronized dancers. Their molecules are all the same, resulting in well-defined melting and boiling points. Now, imagine throwing a few clumsy dancers into the mix. They'd disrupt the synchronization, wouldn't they? That's what impurities do to substances. They disrupt the regular arrangement of molecules, altering the substance's melting and boiling points. Impurities generally lower the melting point and may raise the boiling point of a substance. This is why salt is used to melt ice on roads in winter. It lowers the freezing point of water. Section 4. Factors influencing melting and boiling points. We've already learned that impurities can mess with melting and boiling points. But guess what? Other factors can also play a role. One of the most important factors is pressure. Ever noticed how water boils faster at higher altitudes? That's because the air pressure is lower, so water molecules can escape more easily into the gas phase. The type of substance also matters. Different types of substances have different types of bonds holding them together. Stronger bonds mean higher melting and boiling points. For example, ionic compounds like table salt have very high melting and boiling points because of the strong electrostatic forces between their ions. Another factor is the size and shape of the molecules. Larger molecules tend to have higher melting and boiling points because they have more surface area for intermolecular forces to act upon. Section 5. Applications in everyday life and industries. Understanding melting and boiling points isn't just for scientists in labs, it has tons of real-world applications. For example, knowing the melting point of a metal helps engineers choose the right material for specific jobs. You wouldn't want a metal with a low melting point in a jet engine, would you? Melting points are also used in cooking. That's why we use butter, which has a low melting point, to make things creamy and delicious. And let's not forget about chocolate, which melts in your mouth, not in your hand. Boiling points are equally important. They're used in distillation, a process that separates liquids based on their boiling points. This is how we get gasoline from crude oil and how we purify water. Section 6. Conclusion. Why do melting and boiling points matter? So, there you have it, the fascinating world of melting and boiling points. We've learned that these points are like fingerprints for substances, helping us identify and understand them better. We've also discovered that factors like purity, pressure, and the type of substance can all influence these points. And let's not forget about the countless ways we use this knowledge in everyday life and various industries. So next time you see an ice cube melting or a pot of water boiling, take a moment to appreciate the science behind it. It's pretty cool, wouldn't you say? Stay curious, my friends.